Hello, my name is Steve Browns and welcome to this video on brake performance assessment. It's been over 12 months now since DVSA issued the latest version of Guide to Maintaining Roadworthiness, which was made available in April of last year. Lots of changes in the guide, but probably the most amount of changes relate to section 5.3 brake testing. We've had lots of questions about brake testing. There's still operators out there that aren't aware of what the new requirements are, and the new requirements set out a new process effectively on how you must test your brakes and the order in which things should be done. So we're going to go through that process now, and DVSA always provide all the information. Pages 52 and 53 of the guide are out on the screen in front of you, and this is all the information that you need. But typical of DVSA, they put all the information there, but they don't necessarily put it in the right order. So we're going to have to bounce around the guidance a little bit to reorder it, put it in the correct order to create a process, and at the end of the video we'll put that process to the test. We'll create a little flowchart so you can see how in practice this guidance can be applied. The first thing we need to realise is that every inspection needs to assess the performance of the brakes. So we need to have a brake performance assessment at every inspection. That's not changed, but what's changed is how we go about that inspection and the results that we need to achieve. So we'll bounce across the page to the next little nugget of information, and here DVSA are referring to legislation. They're referring to the Road Vehicles Construction Use Regulations of 1986, section 18.1, where it says that every part of every braking system and the means of operation thereof fitted to a vehicle and reed trailer as well shall be maintained in a good and efficient working order and be properly adjusted. Those last four words are very important in relation to the new guidance, and we'll come back to those later. But every part of every braking system must be assessed at every inspection. How do we do that? Well, DVSA start off by suggesting that we should use EBPMS, electronic brake performance measurements. We find that EBPMS is not in widespread use through our smaller fleets or even medium-sized fleets. It's probably most commonly come across in a hire or a lease trailer. So we're not going to deal with EBPMS in this video. We're going to create another video specifically about EBPMS. But the next option is calibrated roller brake testing, and clearly calibrated roller brake testing testers are common. The equipment's quite common. It's what we use at MOT, and so that's our option number one for carrying out our brake performance assessment at every inspection. That little paragraph there finishes off mentioning plate brake testers. Again, brake plate testers aren't in common usage, so we'll still use calibrated roller brake testing as our preferred option. Our other option, an approved and calibrated decelerometer or a tachometer, otherwise known as. These are not smart pieces of equipment. They sit in the footwell, the passenger side of the vehicle, when the brakes are applied, when it's being driven at 20 kilometers an hour on a flat surface, and effectively measure the performance of all of the brakes operating at the time to bring the vehicle to a halt, and measure the rate of deceleration. So they're not a very smart piece of equipment. They can't identify braking efficiencies of particular axles and single axles out, and they can't identify the braking performance of individual wheels on an axle like roller brake testing can. So it is very much a second-rate system. To try and put some more information into the system to illuminate the printout that comes out of the device, which is going to give an overall percentage efficiency, we must take temperature readings of the brakes, and that can be done quite easily by means of a temperature gun obtainable off the internet for about £25, and we need to measure a number of temperatures. We need to measure the temperature of the air around us, called ambient temperature, and then we need to measure the temperature of each of the brakes on all of the axles. And the first thing we do is compare the temperature of the brakes to the ambient temperature, and clearly the brakes must be warmer or hotter than ambient temperature to indicate that they're being applied. And then we compare the temperature of the brakes on one side of the axle to the other side of the same axle. If the temperature readings are broadly similar, it means both brakes are working together. If one temperature is significantly hotter than the opposite brake, then we've got imbalance there. We've got one brake working much harder or performing much better than the other brake, and that is going to translate to a feeling that the driver gets through the steering wheel of the vehicle wanting to pull to one side or the other, which is clearly not a good state of affairs. So what we're doing there is identifying an imbalance, and imbalance is significant because it relates back to regulation 18.1 of the construction use regulations, in the fact that the brakes need to be properly adjusted. We'll come back to that later because that is the significant change that's causing the major problem in the understanding of how we need to carry out brake tests. So as long as we understand that we have two options now, calibrated roller brake testing and an approved calibrated decelerometer, those are the only two options available to us unless we manage to find a brake tester or we've got EBPMS. Where is road testing? I hear you all shout. Well, we can't do road testing anymore on goods vehicles and passenger carrying vehicles. Road testing can only be carried out on small trailers up to 3.5 tons with overrun brakes. It's now not an acceptable option for goods vehicles or passenger carrying vehicles, so we're down to RBTs, roller brake testers and decelerometers. The question of whether we should be laden or not is asked quite often, and the answer to that is yes, we should be achieving at least 65% of the gross axle weight of the vehicle. We have to do it at MOT, and we should be doing it for an additional 3 brake tests spread evenly throughout the year, making 4 in total. If you're on 6 weekly inspections, that means every other inspection should be a properly laden roller brake test, but we're suggesting to Steve Browns and Associates that every inspection you should aim at having a properly laden roller brake test. If we get that into our planning now, then we'll be ready for next April, because the next part of the guidance DVSA is suggesting that in next April laden roller brake testing will be an expectation for every inspection. Now, the result of the guidance on pages 52 and 53 have meant there's been an increased demand on roller brake testing time. We've got operators that are fitting their own equipment. We've got maintenance providers that haven't had a roller brake tester and have relied on a third party to provide that, and now fitting roller brake testers. But there's been a big increase in the demand for roller brake testers, which is only going to get worse as we go towards April. So our advice is this: have a laden roller brake test at every inspection now. Develop that relationship with your maintenance provider so that you've got an expectation that every time your vehicles go in, they have a laden roller brake test. And then come April, that you're going to be at the head of the queue. You're going to have your planning already done. Your maintenance provider will already expect to carry out a roller brake test, and will have that planned into their diary. There have been some mutterings out of DVSA within the industry that the April date might not be met because of the lack of roller brake testing equipment in the industry, so it may be put back. But if we aim for the April date and we're ready for the April date, then if we are put back, at least we've got our planning in place and we're ahead of the queue when it comes to roller brake testing time. Okay, let's move on. Let's look at the next piece of guidance, and that is when we should have the roller brake test. In previous Guide to Maintaining Roadworthiness documents, it's said it's been acceptable to have an inspection and a roller brake test in the same ISO week. So in theory and in practice, it was okay to have an inspection on a Monday and to have the roller brake test on a Friday, and for both of those pieces of paper to come together to form a full inspection. However, now we must have the brake performance assessment in the 7-day period immediately preceding the inspection. On the same day as the inspection is fine as well, but it needs to be before the inspection is carried out. And it all relates back to those last 4 words in Regulation 18.1 that says the braking system needs to be properly adjusted. So we'll come in on to the issue, the crux of the issue that's causing a little bit of misunderstanding about when a brake test is passed, when it's not passed, when it's acceptable, when it's not acceptable. Further, we need to record some information about the brake performance assessment on our inspection sheet, and for every occasion we need to record the date of the brake performance assessment, how it was carried out, and the condition of the vehicle, i.e. whether it was laden or unladen. That's for every inspection. Now, where a piece of equipment doesn't give a printout, and some decelerometer piece of equipment don't, then we need to write on the inspection sheet the performance of the brakes, the percentage efficiencies that the brakes achieve. But other than that, for every inspection we need to write in the date of the assessment whether the vehicle was laden or unladen and the method of assessment that was used. Regarding the printout, now we'll probably talk about printouts from roller brake testers in the main, but decelerometers also give printouts. These must be signed. Decelerometer printouts quite often have got a dotted line for the operator to sign on and to print their name. Most of the time roller brake tester printouts don't, but the requirement now is for all printouts produced by brake testing equipment to be signed by the person operating the equipment. And we'll come back to 18.1 and look at that requirement for every part of every braking system to be in good efficient working order and be properly adjusted. And the properly adjusted thing we'll get into now, because there is a requirement. There always has been a requirement, but now it's a specific identified requirement. It's written down that a brake test report must be reviewed and understood by someone within the process, and we would suggest that it's going to be a transport manager who has knowledge of the guidance that is being required to be followed. Could be an operator, and it should be a maintenance provider, but the brake test report, hot off the press, needs to be examined by someone that has knowledge of this process so that they can make an assessment of whether the results on that brake performance assessment printout are acceptable or not. Because we might have a pass for the actual percentage efficiencies, but because of other parameters, that last paragraph on 53 identifies that it may well say passed at the bottom in terms of the percentage efficiencies, but because of other issues that might be identified in the brake test report, the brake test might not be satisfactory. So now we have to have a pass plus a satisfactory to get a complete pass, and then to move on to the next part of the process, which is the inspection. So what's satisfactory, what's not satisfactory? Well, not satisfactory is the presence of deficiencies, and it's mentioned there if deficiencies in the brake performance have been identified either during the use of the vehicle or at brake performance assessment, then the vehicle will not be considered roadworthy. Unhelpfully, DVSA don't provide a definition of deficiencies, but we know from the inspection manual, from other documents, that deficiencies variously can be bind, which is brake pads or the brake shoes not releasing from the disc or the drum properly. Time lag, which is the difference in time between the brake being applied by the driver and the brakes actually applying at the wheel end. Ovality, which is a brake drum that's kind of egg-shaped, so that on each rotation the brake drum is effectively pulling away from the brake pads. and then imbalance. And imbalance is the most common form of deficiency, and that's the one that's going to give you most problems. So we're going to have a look now at a brake performance printout, an RBT report, a recent one, a real one, which we've anonymised, and we'll go through it. And the first thing that we can see is that the overall result is passed. And that's in the main what operators look at. Once they see a passed marker, this piece of paper will then go into the vehicle file and probably be forgotten. But because of the requirement for it to be examined by someone that's knowledgeable about brake test reports, we need to look further. So we'll go through the brake test report. I'll go through in the order that I would go through, but as long as we get all the parameters examined, it doesn't really matter what order you go through. I would probably look at the insufficient load in axle 3 and 4 and look at rectifying that for future brake tests. This is a 4-axle rigid vehicle, and in general they do suffer with issues on getting load in the right place to put an equal load on all of the axles, but we do it for MOT, so why can't we do it for every other inspection? Moving on from there, the next thing we normally do is look at the percentage efficiencies and the pass values. You're probably well known to you: 50% for the service brake, 25% for the secondary brake and for the split system and the secondary if there is one, and 16% for the parking brake, or 12% depending on vehicle type. So on this occasion it's 16%. And I'm looking at that first value outlined in red, and the test value is 42% and the pass value is 50%. So clearly there's 8% difference, and that should be a fail. But why is it passed? Well, it's passed because the wheels have locked. Locked wheels aren't good. And the way that we get to the point between putting our foot on the brake and wheels locking is significant, because what we've got here is a brake that the driver's applying. Ideally we want to be able to apply the brakes progressively, so every millimetre of travel of that brake pedal gives us a proportionate response of braking at the wheel. But what we have when the wheel's locked is the driver puts the foot on the brake, nothing happens, nothing happens, nothing happens, and then the brakes come on and lock the wheel. Clearly that's not acceptable. It's acting as an on-off switch. So I wouldn't be happy, even though this test has been passed. It's only just passed. It's scraped the lowest level of pass possible, which is a pass because the wheels have locked. Moving down to the secondary, we've just met the performance value there, 25%. FWA in bracket, by the way, if you don't know what that is, it's front wheel lock allowance, where there's an allowance made because the front wheels are actually locked. The secondary braking system on the split system, we haven't achieved the pass value, but we've passed the test just because, again, the wheels have locked. And the parking brake has achieved and exceeded the pass value. So all in all, not a good brake test, but one that has just met the criteria of the maximum force applied. We've just met the criteria because the wheels have locked. So that's the first part. We've passed the test in terms of the performance, percentage performance values. We now need to look at the issues of deficiencies, because we need both a passed brake test and one that is satisfactory in all other elements. So it's those other elements that we're going to look at now. We've mentioned earlier bind and then lag. Bind, occasionally you might see a failure. Lag, time lag isn't measured by the brake testing equipment. That's something that would be assessed by the operator, and you will always get a column full of passes there. Ovality, very occasionally you might get a failure for ovality, but the most common one, as we said earlier, the most common deficiency is this issue of imbalance. So we're going to have a look at this column in more detail. The criteria for imbalance for MOT failure is more than 30%. So at more than 30%, a vehicle will fail at MOT. There is a caveat to that if all wheels lock, then the vehicle will scrape a pass. And I keep saying scrape a pass because locked wheels aren't good. We want to get good performance values with low imbalance, but more than 30% is a failure. And then there's another criteria which DVSA introduced, and that's their intervention level at more than 25%. So where we have imbalance more than 25%, so 26% and above, DVSA advise operators that they must carry out an investigation to find out what's causing the imbalance, to rectify the issue so that the vehicle can then be tested and a new brake test report produced to show that that imbalance has been either eliminated or at least reduced to below the intervention level. So looking at this report in more detail from the bottom up, axle 4, you can see there that the service brake has an imbalance of 23%, which is very, very close to DVSA's intervention level. So that's a developing issue. But if we move up, we can see that axle 3 service brake has an imbalance of 39%, well above DVSA's intervention level and well above the MOT failure criteria of more than 30%. So although on the face of it, this brake test report looks like it's been passed, it may well have been passed on performance because the brakes have locked, but it's not satisfactory, and under the new guidance it is not acceptable. The vehicle is not considered roadworthy because of that imbalance. So what happens now? Well, we go back to that paragraph on page 53 and we follow the process through. So where that imbalance is unacceptable, and it's unacceptable at 26% or more, then the operator must investigate what's causing that imbalance, make a rectification, and then submit the vehicle for a further brake test to show that the imbalance has been reduced to below the intervention level, ideally eliminated altogether, and then a further brake test report produced to prove that. It then can go for inspection, and only then. And that's the issue. Operators are sending vehicles in for inspection because they can see past at the bottom of the roller brake test printout, but with deficiencies present that render the vehicle unroadworthy. So let's look at a flow chart putting all that information together. Quite a simple process once you get your head around what needs to be done and when. What we need to achieve is a passed and satisfactory roller brake test. We'll look at the printout that is produced by the equipment, and someone with knowledge of brake testing and of the guidance on pages 52 and 53 needs to make an assessment of whether that brake test report, is both passed and satisfactory. And the satisfactory obviously relates to these issues of deficiencies, primarily imbalance. If it is passed and satisfactory, then we can send the vehicle to inspection, no problem. If it isn't satisfactory, then the vehicle goes in for rectification and then back round to have another roller brake test. And that little circle there of it's had a brake test, it's not satisfactory, we've done a rectification, we've then gone back into a further roller brake test, it may not be satisfactory again, so we're back out to rectification, and we go around that process until we've identified what actually is causing the imbalance, it has been rectified, and the vehicle's gone in for a roller brake test, and both a passed and a satisfactory brake test has resulted. Once we've got that, the vehicle can then go for inspection. As we know, we've already mentioned, it must be within 7 days of the brake test. So we've got that 7-day window once we've done a satisfactory brake test to have the inspection. That the vehicle must be accompanied by a signed roller brake test report. This needs to be given to the maintenance provider, and that's so when they carry out their physical inspection of the brake components, They can have knowledge of the fact that this vehicle's brake components actually work as they should, as well as being in good condition physically, that they actually produce the desired result when the driver puts the foot on the brake, so that once the inspection is completed, the maintenance provider can sign the declaration of roadworthiness in good faith, knowing that their physical inspection plus the brake performance assessment as a whole mean that the vehicle is roadworthy and the brakes are operating correctly and are adjusted properly. And we need to retain all roller brake test reports to create an audit trail of the process of testing, of it not being satisfactory, of our process of rectification, back into retesting to a point where we've got a past roller brake test report which is also satisfactory, and then we've achieved a roadworthy vehicle. So I hope that's been helpful for you. As I say, we'll produce a further video on EBPMS, but for now we hope you've enjoyed the video and it's been useful, and safe driving.